Hello students, welcome to another session of coordinate geometry. Today we'll study about the locus. So locus is very important chapter in the coordinate geometry. So what is locus? Locus is a collection of points that share a common characteristics and follow a specific rule. The rule can be expressed as the algebraic equation, and the locus represents the location and path of all points that satisfy the equation. So suppose there is a straight line which is having 2 points, like suppose here is a point 0 3, and here this is a point 2 0, and the line passing through this. So any point on this will satisfy, like suppose this point, this is what 2.2, 2.4. This is point 2.4 by axis. And what is the x-axis? X-axis is just point 0.2. So 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2. This is point 4. Sorry, it's a point 4. So this point is point 4 and 2.4. So this should satisfy this equation. So put there point 0.4 divided by 2 plus 2.4 divided by 3. So this is a point 0.2 and this is 0.8. So that is equal to 1. So this point is satisfying this equation. So locus of that line is that all the points on this line is x by 2 plus y by 3 is equal to 1. So how we can get those equations, that we'll see in the next chapter. First we understand more, take more example about the locus. Now we want to know the locus of a point that are equidistant from the fixed point, and that we know just one fixed point and it's equidistant from all the points, then it will be definitely a circle. So let alpha beta is the fixed point, that is center, and the radius length, this length is a. Then the equation of that circle will be this one. So here you see this center is 2 3, so alpha beta is 2 and 3, and the 2 and 3, and the radius is 2 square. That means radius is 2. So this is equation of circle that you can know from the website called desmos.com. You can go to desmos.com, write this equation, you will get this circle. Now see some other example. This is the 2 point, that is 2 5, that is 2 5, and itna. And the locus of the all the point which is equidistance. Equidistance means this distance and this, from here to here distance and from here to here distance will be equal. From here to here distance, to take any point, the distance from these two points will be equal. So how you can find the equation? So just you do y minus y1 plus y2 is equal to x2 minus x1 divided by y1 minus y2 into x minus x1 plus x2 divided by 2. So this way you will get this equation. Y minus 4, how 4? This one y1 plus y2, 5 plus 3 divided by 2, that is 4. And this one you will find that will be 1, and this x1 plus x2 divided by 2, s2 plus 4 divided by 2 is 3. So this equation of this line will be y minus 4 is equal to x minus 3. So what is that? This is the perpendicular bisector of the two line joining of 2 points, this one and this one. So if we know these 2 points, we can find the line joining, perpendicular bisector of this line joining. Now come to the next example. Next example is that suppose two lines are there, this one and two lines are there. So what is this line? This line and this line. And the angle bisector. See, this one is angle bisector. This one, two lines, one acute angle bisecting and that is a two angle bisecting. So there will be two equations. And suppose this one is one line, this one is two lines. So we can find out the angle bisector. This one is one line equation. This is another line equation. Now come to the locus of a point which is having, suppose one line is there. So this perpendicular distance, and from the point this distance and this distance is equal. Any point you take on a parabola, any point, this distance and this distance will be equal. You take any point here also, so this distance and this distance will be equal. If those points you just take all those points, this will be this curve. This is the equation. So what is the equation of that? Y is equal to 4ax. What is a? A from this vertex to this distance is called a, and this is also a. So this line equation will be x is equal to minus a. So now come to the next example. That is example of ellipse. Suppose this one is d1 and this one is d2. You take any point. This one is, suppose this one is c1 and c2. If d1 plus d2 is equal to c1 plus c2 plus n, take another point, and that is e1 and e2, that is e1 plus e2. If this is the point, itna is suppose is equal to 2d. 2d how can? Here you meet, this one is d. So the equation of the ellipse will be x square by d square plus y square is equal to d square minus c square is equal to 1. What is c? This two fixed point, minus c0 and c0. So all those you connect all those points, you will get the ellipse. So how you will get that? So you understand the locus? Locus is all those points which is following this condition. This condition means x square, x d1 plus d2, c1 plus c2, e1 plus e2. So many, whatever the points on this is always will be equal to 2d or equal to any constant. So if you connect all those points, you will get the curve, and that curve is called locus. So locus you can define by the drawing curve, or by equation. So suppose one equation is there, y square is equal to 8x. You put value, that is x and y. Suppose we put x is equal to 0, y is equal to 0. X is equal to 1, y is equal to root 8. X is equal to 2, y is equal to 4. So all those points you meet and you will get the parabola. So this is all about locus. Next chapter we'll study how to find the locus on certain conditions. Thank you.